All right, I'm Logan Bertling. I'm a project engineer with Drucker Zidell Structural Engineers, DZSE. So the way I guess I explain it to people who aren't engineers, like family and friends, are like, what do you do? I try to tell them there's one engineer and an architect, and they're designing all the beams and the columns and the framing in general. Eventually, it gets down to a steel fabricator who has to make all these pieces, and then they'll call us and say, like, how do we put all these pieces together? In terms of like structural design, I guess it's just much more of a smaller scale thinking instead of like, usually you're thinking about the entire structure as a whole and how it's behaving and what the building does when the wind blows on it and just like big picture stuff. And we're very, very small picture. Like we're thinking about every single bolt and weld and every hole that you're drilling into every little plate and stuff like that. So it's kind of a different mentality. And you also have to understand the bigger picture stuff when you're doing connection design, because you need to kind of understand where the forces are coming from and where they're trying to go in order to design your connection. Because you can look at the framing on the drawings and be given the loads, but sometimes not, it's not always explicit or super clear, and you kind of got to figure out like, all right, like what's the actual goal here? What was the other engineer, what was their thought process? Where are they trying to get this load? So you do still have to understand both sides of it. They have a good feel for when something seems right or if something seems wrong. And a lot of times, if there's like some complex framing, they'll even help us come up with just like conceptual ideas from, past projects that they've seen before, like, oh, we could do something like this, and they'll let us know what types of things they can fabricate too. I'd say it's a lot more collaborative. The main structure is always done by the time we get in, because we need to use those drawings to come up with our price to figure out how long it's going to take us to do all the connection design, and we'll get sent preliminary versions of drawings along with the contractor and the fabricator, and they'll send like initial bids, and then once they get to, I don't know, like 90% drawings, or like sometimes they'll send like schematic drawings or design development or whatever level they're at, and then they'll send the updated set, and you just kind of refine your bid from there. But yeah, that side of things is always done by the time it gets to us. But then fabrication and erection, that'll happen like simultaneously. Like they'll get going as soon as we get, I don't know, couple floor head start. They'll start fabricating, and then erection will start, and we'll still be designing, the mid levels as we go up. It's just staggered a little bit. You always want to ask, with every fabricator, like what kind of preferences they want, because even like certain fabricators, they'll change from project to project. Like just for typical connections, a lot of times they just want to use like a simple shear tab on one project, but then the next one, they might be like, oh, we got a crap load of these angles lying around, like let's use like single angle connections or double angle connections next time. So like it's always changing, and then every engineer of record is different, and they have different requirements. So like there's always like a lot of questions to ask in the beginning, a lot of like setup just in terms of like our spreadsheets and stuff like that. A lot of times when a fabricator gets a project, they'll kind of go through the erector. Like the erector is to the fabricator as the fabricator is to us, sort of like they're their client kind of. And they'll establish at the beginning of a project if they're just going to field weld all the moment connections or not. But when it's built into like the project in the beginning like that, everything's fine. Like they know they're gonna field weld, so they have a welder on site and he's gonna be doing stuff all over the place. But on a project where they're bolting, if you have to field weld anything, it's like extremely inefficient to have a welder go up and like bring all his equipment up to this one specific spot and then weld it and then move on to somewhere else. Whereas if he was welding everything else around it, there's not as nearly as much like mobilization cost, I guess, with it. So field welding in general, if you're not welding everything from the beginning, is like extremely taboo. Like anyone will do like the craziest bolted connection before they want to field weld. There was some like steel built up grade beams that tie those arches kind of come down on all four sides of the building, and then there's these grade beams, and then they kind of tie all those arches together. So they have some crazy high forces, and I just did some splices. I think like my splice plates were like 3 inches thick, and I used 1.5 inch A490s It's a box member, and we had bolts all the way around the box, and then we had to drill access holes in the sides of the box and have more bolts on like the inside. I think there was like 90 bolts on this like splice, and they still wanted to do that than field weld. In the beginning, like when you're going through school and when you're first starting engineering, it's kind of funny how much my mentality's changed a little bit. Because at first I'm kind of worried about trying to remember like load paths and like all the limit states, and I'm like okay, there's yielding and there's rupture and there's bearing and tear out and you're trying to like remember all this stuff and not try to like mess anything up, like all the calculations and the numbers and the academic related stuff. I'd really say even just after a few years of doing this, since then it's kind of flipped. All that stuff's just like the back of my hand. I don't even really think about that. It's all been more about like, okay, like, can they build this? Is the fabricator gonna like this? Is this like an efficient, like reasonable connection? And there's a lot of, I would say, creativity with connection design. Like you can think through all these different concepts. You know, you're looking at a couple lines on a drawing and with these loads, but there's a lot of stuff where you really gotta like think about like, you know, from the start and just try to picture in your head. But you're not necessarily thinking about the numbers. You're kind of thinking about like, you know, erectability and like just the strength and the way the connection is going to behave in general. I don't know how to describe it. It's just like funny how my mentality has changed, and you get more comfortable with like the numbers side of things, and now it's just more abstract thinking and like conceptual thinking and thinking in like 3 dimensions. And I was like so scared to talk to the fabricators when I was first out of school because I didn't want to say something stupid or like, you know, like they'd be like, this kid doesn't know what he's talking about. You know, like they're gonna know I don't know anything. You know? But since like it really doesn't take too long at all until you're like comfortable with, like really once you get comfortable with the numbers side of things, you start to get more confident. And like before you know it, stuff you were like super nervous about in the beginning is like nothing, you know?